Hello, beautiful viewers. You're welcome once again to another fascinating math video. It's been quite a while now. I must tell you the truth, I've not been fine health-wise, but thank God today I'm okay. So I hereby present to you another video, but this time around we are looking at problem from analysis. I would still like to add that if you are in need of a private online math tutoring service, it can be private or group, whichever is the case, be very free to get across to me via my WhatsApp number or you message me directly, because I render exclusive service when it comes to this demand. I have an ample experience on tutoring various levels, high school level, secondary, primary school, even to the university level. Alright, so be very free to get across to me for such a service so that we can make arrangements regarding how the class should be organized. So quickly go over to the solution of this particular problem. Over here, we are given two functions, and these functions are defined piecewisely. The first is f of s equals to 1 minus x for x less than equal to 1. While the other part of the definition is 2s minus 1 for s bigger than 1. That is all for the function f. Then over to the function g of s is equal to 0 if s is less than 2 and equals minus 1 if s is bigger than or equal to 2. So we are required to find the sum of the function f plus g and the domain of that sum, also the difference of the function f minus g and the domain of the difference. And lastly, we are required to find the products of the functions and the domain of the products. Alright, that is the first part of the question. Then number 2, we are required to form the composition f composed with g, or you simply read f circle g, and we are to give the domain of the composition so formed. Alright, so let's look at the first of the problem. First of all, we bring down our functions. Solution. We are given that f of x is equal to oh, this is not well drawn. Alright, we can manage this. We have 1 minus x for x less than equal to 1. X is less than or equal to 1, alright? Then we also have 2x minus 1 for s bigger than 1. Then the other function here, we have g of x also defined piecewisely as we have 0 for x less than 2. Then we have minus 1 for x bigger than or equal to 2. Alright, so one thing you should understand, in trying to find the sum of functions, we must determine the domain. When dealing with function, domain is very important. Many people deal with function blindly without considering the domain of the function. Alright, it is very important to consider the domain of a function when dealing with function. Now, if for us to find the sum g plus f, or you say f plus g, whichever, we must consider the domain of the function g and f and look for the intersection of the domains. Because if we have a function f and we have a function g, in order to find f plus g must be defined on the domain. In other words, the domain of the function f plus g is equals to the domain of f intersects the domain of g. That is, we must look for the intersection of these two domains of function f and g. and the intersection will define the domain of the sum f plus g. All right, so we must do that. So how do we go about that here? If you observe carefully, the function is piecewisely defined. All right, first of all, let's locate the domain of the function f. Now take note, we can say the domain of the function f is equals to the set of all x such that x is less than equal to 1 union the set of all x such that s is bigger than 1. You can see that here. Can you see this? Look at this. This form the first set and this form the second set. So the union of these two sets, which is this, will be the domain of the function f. Writing this in interval form, we can have it as, since s is less than or equals to 1, we can have it as minus infinity to 1 inclusively. All right, the union, the same thing happens here. Since s is bigger than 1, that means we have 1 exclusively to infinity. So this is the domain of the function in interval notation. All right, so we shall break up this domain such that the function f and the function g will have intersections for which the value will be defined. All right, so let us look for the domain of g first. Let's look for the domain of g before we do the breakup. Now, domain of g is equal to writing. Now, in this case, we can say a set of all x such that s is less than 2 union set of all x such that s is bigger or equal to 2. Now, writing this in interval notation, we have the result as since s is less than 2, we have minus infinity and ending as 2 exclusively union. Now s is bigger than 2, that means we start from 2 ranging to infinity. All right, so we have these two domains at hand. So what we shall do, we shall define in order to get the sum. Please take notes, this you see here can simplify to writing minus infinity to infinity. All right, while this can also simplify to writing minus infinity to infinity. So in effect, the two functions have the same domain. All right, can you see that? Now, how do we get the sum? Okay, now observe the first function carefully. This over here, observe this over here carefully. All right. Now, if you observe this function, you will see that the value of a possible value of the function is 1 minus x, and that holds when s is less than or equals to 1. In other words, when s is in this domain, look at it here. Can you see that? When s is in this place, that is 1 to infinity. Now, looking at the function g, we can see that there is an intersection between this interval and this interval. And what is the intersection? The intersection is simply this. All right, the intersection is simply this. Can you see that? Because this you see here is common to this, and this is included in this interval. If we are to represent in a number line, for example, let me represent so you can get what I'm talking about. Let's say this is a number line now. Let me use this side. This is a number line, right? Then we have 2 as a result here, and we have 1 as a result here. Now, since in this domain G, since s is less than 2, we can draw the number line as follows, and the arrow will point to the left, right? This shows that x is less than 2. Then, since in this one you are seeing here, since x is less than or equals to 1, we can have it as follows. Then you can see that this region is a common region to both of them, and this region defines x to be less or equals to 1. So in other words, the intersection between these two intervals is s less than